everyone, welcome back to my channel EduVibe. Today we will start with the last topic of momentum and impulse, which is the combining the conversation laws. So in this we are dealing with the laws when we combine them all. We combine the momentum law and the energy law to find something. Which is that thing we have to discuss today. So let's deal with this. How can we do it? Firstly, we deal with the conservation of energy. So, conservation of energy, you all know that this is EKA plus EKP is equal to EKB plus EKBB. So, this equation you don't have in your data sheet. So, this have to be remembered. So, this equation we will rapidly use in the overall all the units. The rest of the three units we use this equation again and again, and then we know that how this will be used. Today we will know that. So that EPB is equal to the mgh. So this is the potential gravitational energy, or we can say gravitational potential energy. We take it as mgh. Parameters, you all know that g is 9.81 meter per second, and that ek is your kinetic energy, all you know that, which is half mv square. We have to use the same one. How we use? Let's move on to the example and then we figure out how can we use. So here we have a diagram, and they just say that we have to find the speed of both the cars after the collision. So after the collision, what their two cars doing? So they start from there. This is 600 kg cart. They going with a velocity of 7.50 meter per second, and they recline down over there, and this is our rest of the another object, another cart, or it is in the rest. And when they collide in this, like this object 600 kg one, when they collide with this, or we can say hit with this, so they stick together like this. So the both objects stick together, and we want that what is the velocity over there. So to find the both after the collision. So this means it's a hit and stick collision. So to use the momentum that thing. So also we have that height over there. This is our height, which is 5.00 meters. We have a mass for both. We have that this is in rest. So this have the initial velocity of 0. So this has the initial velocity of 0. This was the V1 and this was the V2. This has number 1 cart. This is 2, then 1 and 2 combine both. So this is 1 and 2. So we have to find that hit and stick. This is the hit and stick collision. So we have to use a formula for hit and stick. So we P1 plus P2 will give you P12 final. So that P2 goes out because this is in a stationary first. So that P2 goes out. So we're left with M1 V1 I is equal to M1 plus M2, which is V12 final. So that V12 final we have to find. So V12 final is equal to M1 V1 I upon M1 plus M2. So that is equal to M1 is 600 kg, but we don't have V1I. That 7.50 meter per second is not our V1I. So why it is not V1I? This is our velocity initially. But we find that when they recline down over there, when they on over there. So what is that initial one when they put over there? Because when they recline over there, the speed is increased. So this is not 7.5. So that speed is increased when they go from the height of 5.0 meter to the down. So that increased height is our V1, not that which we have 7.50. It goes from when it goes from here to here. So that is 7.50 meter per second, but this is not 7.50 seconds. Have to find that. So how can we find that? Because there's a height and there's a gravity goes out. So it's an energy type of concept. Because we have a kinetic energy initially is this. After what is this when they decline down? So For this type of questions, when we have a situation like this, in a hit and state, we have in hit and state, we have type of this equation situation. So EKA plus EPA, EKB plus EPB. So EKA we have, EPB we have to consider because we have that height of 5.0. The EPB, but our EPB is goes to 0. So why it goes to 0? Because when they collide with this, it's at rest. So not have any thing over there. This is in the rest and they didn't like move. When the first object goes with this, they collide with this when they move. Initially they have a nothing and the final they have nothing. That final we have to find. So that EK is half MA squared plus we know that MG HA, which is our height A, and that EKB is half MV. So we have mass over there, mass over there, and mass over there. When we take mass over there common, and this is our mass multiply, that all masses goes out. So we're only left with half VA square plus GHA equal to half VB square. What we have to find? We have to find the VB. The VB tell us that how much velocity they have after they climb down. VB we have to find, which is equal to VA square plus 2 GH. How it comes to there? I know you have to figure it out. How can them say? So I skip those steps. How then it comes to there? So I know you have to know that this. So this is 7.50 meter per second square. This is 9.81 and this is 5.0, which is our height. So the VB we get when we calculate about 12.423 meter per second. This is also equal to our V1, which we have to put now over there. So that is 12.423 meter per second. M1 is 600 kgs plus 800 kgs. So we want to final, we get about 5.3244 meter per second, but we want only 3 set this. So our combined mass, our combined final mass is 5.32 meter per second. So that's the thing we have to find. We find with that little bit work. Not like too much for like in the vector questions. This is like a quite easy work we do in this. So that's how these questions work when we combine the both laws, momentum and the energy law. Now we on to the ballistic pendulum. So the ballistic pendulum is the kind of the projectile motion we do. So the projectile would be fired at the pendulum and become abundant. So what they said that I have to explain this. So this is our something like the box over there. This is a pendulum, and we hit from the gun something like the bullet we put, and this goes out in this, and then this goes inside this, and when they hit this, they hit over there. This is so the when we fire a bullet from a gun, so it's a hit very fast. This is velocity is very high in that case. So when this velocity is very high, so this at pendulum like this, because they hit a very large velocity. So that's how what is called the ballistic pendulum. So the system consists of projectile, which is the bullet, and the pendulum will swing together to some maximum height. They go to some maximum height in this space when that hit in the very high speed. So through use of the principles of conservation of energy and momentum, this would allow a person to determine the speed of the projectile peer to impact in the pendulum. When the pendulum hit that projectile, the speed will have been determined with this impact. That is called the ballistic pendulum, which is in the modern era, we say. So this all thing, if it is in a kind of question, so what will happen? So here's the question for the example like this. There's just one thing we have to know, that what effect they blows to the pendulum when they fast moving object, fast moving bullet hit towards this. So we have a mass of the bullet, which is 0.0234 kgs. From a gun strikes 4.0281 ballistic pendulum. The pendulum is about that kgs. Upon impact, when they goes to impact, the pendulum swings forward and rises to a height of 0.373 meters. Determine the magnitude of the velocity of the bullet immediately before the impact in meter per second, and for the two physics principle used in this. So the physics principle parts I will discuss later on. So first we have to find that what is the magnitude of the velocity bullet immediately before the impact. So how does it happen? So we have that pendulum, that bullet goes over there. When the bullet goes, it's like this. The bullet is over there, and they hit, and they go to some maximum height with that. So that is the maximum height of this. So that means that if the bullet has separate mass, this has a separate mass, but when they goes like this after the collision, they go on the combined mass. So it is the combined mass. So this means this stick in this. So this means that we treated it as a hit and stick collision. So the hit and stick collision have their own formula. That P1 plus P2 will give you P12 final. So but that our pendulum is at rest initially, so this goes to 0. That bullet is not at rest, they move in with the high speed, so we have to take this. So m1 v1 I is equal to m1 plus m2, and we have a combined. What we have to find? We have to find that before the impact. So we have to find that v1I. So that v1I is equal to m1 plus m2 combined final velocity upon m1. So that m1 is 0.0234 kgs plus m2 is 4.0281 kgs. That v1 to f we have not there. So we have to find this. We have to find the combined final velocity. So how are we going to find this? Because we have a height over there, is all due to the kinetic energy and the potential energy. So they're moving, so this is the kinetic energy. So we have to find by conservation of energy. So we know that EKA plus EPA will give you EKP plus EPB. That EPA goes out because it initially at rest, and after that they both in the motion they both goes out, and they not telling that they comes down, that they have reached the maximum height, and that was the kinetic energy B for this. So that's not given to us, so we take it as 0. We know that half mv square is equal to mghb. We have to find the VA. So that VA is equal to 2GHB. That mass goes out, and we get this, and the square of this. You know how can I come to this point? So that VA is equal to 9.8 meter per second square. That VHB is given to us, which is the height, which is 0.373 meters. That VA is 2.7052 meter per second. And this is also our combined final velocity. So we have to put this over there. which is 2.7052. And when we find this, when we calculate the whole thing, we get about 468.385, and our we want to increase it this, so we get about 468 meters. So this is our velocity of the bullet immediately before the impact. So this is a V1I. So they're talking about the two physics principle. So the two physics principle we have that from the data sheet. Then firstly we use a conservation of momentum. The conservation of momentum is the physics principle 4. So we use physics principle 4 in that case, and this is the our conservation of energy, and this is the physics principle 5. So what two principles we use? So we use 4 and 5. You can also say that we use 3 too, because we use a work energy theorem. That work energy theorem is also conservation of energy. So 4 and 5, 5 and 4, 3, 4, 4, 3, all are the right option if you get in numeric. You get this type of question in numeric. So this was also for the marks. You have to mention two phase principle if they ask to you. So that's all for this unit now. So we cover all the topics of this unit as the grade 12 curriculum. So this is the unit momentum impulse. From my point of view, this is the easiest kind of unit, but from the rest of all, because the next unit, which is forces and fields, this is a much more like a tricky unit, or we can say it's a hard unit as compared to this one. So now we are doing the practice questions in the next lesson. Then we do some diploma questions of this unit. Then we move on to the forces and fields, which is like a unit which we will start by the end of February. So learning made simple with EduVibe. Learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.